If you've plugged a liquid mosquito vaporizer into your wall recently, you might have noticed a shift in performance. These devices once guaranteed a bite-free night, but lately, that protection seems to be vanishing. They're engineered to release a steady, room-filling protective barrier, yet instead of falling, the modern mosquito is frequently seen passing right through the chemical plume without losing its flight coordination. The insect remains undeterred. It lands, feeds, and leaves with a full blood meal, seemingly immune to the airborne defenses that are supposed to paralyze it. This raises a question about what exactly has changed. Did the chemical concentrations in these bottles drop, or did the mosquitoes themselves find a way to adapt? To find the answer, we have to look at the microscopic level to see how these chemicals were originally designed to shut down an insect's biology. The active ingredients in most vaporizers are synthetic pyrethroids. These are highly volatile molecules designed to hunt through the air and saturate every corner of a room. These molecules drift into the mosquito's spiracles, dissolving directly into the bloodstream. They target the nervous system's voltage-gated sodium channels, electrical gates that rhythmically send signals. Pyrethroids wedge these gates permanently open, causing a continuous flood of charged sodium ions. This state of permanent activation causes the mosquito's nerves to fire nonstop, leading to systemic short-circuiting. The result is rapid paralysis, known as knockdown, followed by the insect's death. This chemical weapon was effective for years, but constant exposure has pressured mosquito populations to develop survival mechanisms. Decades of deploying pyrethroids in homes and agricultural fields killed off the susceptible majority. The only insects left alive were those born with rare, random genetic mutations that offered protection. Mosquitoes evolved to overproduce specialized enzymes, like cytochrome P450s, acting as a cellular cleanup crew. They aggressively intercept pyrethroid molecules on the bloodstream, shredding them into harmless fragments before reaching the nervous system. By destroying the toxin in transit, the mosquito survives the flight through the vapor, without a single molecule ever reaching its target. Even if the enzymes fail to catch every molecule, a second, deeper genetic defense has appeared directly at the nerve cell itself. This is KDR, or knockdown resistance, a genetic mutation physically changing the structural geometry of the mosquito's nerve gates. The pyrethroid molecule can no longer dock with the shifted receptor. It attempts to bond but simply bounces off, leaving the gate functioning normally. With the docking site modified, the mosquito's nervous system is effectively invisible to the insecticide. The insect can remain immersed in the vapor, while its biology continues to operate undisturbed. A single female lays hundreds of eggs. When individuals possessing cleanup enzymes and altered locks survive to mate, they pass those precise traits to the next generation at an exponential scale. As these traits spread, the once lethal vaporizer barrier degrades into a minor environmental irritant. Equipped with these internal defenses, a resistant mosquito can confidently tolerate the airspace, push right through the chemical vapor, and reach its target to feed. That manufacturers traditionally test efficacy in small, controlled chambers, sometimes as small as 6 cubic meters. This creates a high chemical concentration that doesn't reflect the reality of a modern home. In a real-world bedroom, the volume of air is much larger, and common factors like ceiling fans or open windows dilute the vapor to trace levels. When you combine this environmental dilution with the mosquito's internal biological armor, the vaporizer simply lacks the potency to establish a protective barrier. Relying on a single chemical tool plugged into a wall is no longer an effective strategy for preventing bites. Modern control requires a layered approach. This includes physical barriers like screens, the constant removal of standing water around homes, and actively rotating different classes of chemicals so local populations cannot adapt to just one. The biology of the mosquito is continuously adapting. To successfully protect ourselves from vector-borne disease, our countermeasures must be as diverse and unpredictable as the insects we are trying to stop.